In this section, we're going to look at significant figures. The layman definition of significant figures is digits of a measurement that make sense. Digits of a measurement that makes sense. Suppose you ask somebody for the time, and using his hand watch, it says the time is, let's say, 1 o'clock, maybe 20 minutes, and 1.45689 seconds. Okay, so obviously there are some numbers that don't make sense over here. Using a hand watch, you can tell maybe it's a second, but it's very difficult to tell this fraction of seconds. Okay, so there are obviously some numbers that do not make sense over here. What we call significant figures are the digits that make sense. You see the hour, the minute, and maybe the second make sense, but these fractions of seconds do not make sense because they cannot be determined using a hand watch. Now let's look at the scientific definition of significant figures. Suppose we're trying to measure the length of this object using this device. Okay, let's say it's 0, 1, maybe 2, 3, 4, and so on. Okay, so the length of this object is obviously between 1 and 2. Okay, so there is no question that the first digit is 1. And then we can guess this number. Some people might say the reading is 1.5, some people might say 1.6, some people might say 1.7, but we are allowed to guess one number. Okay, but if you're not sure about this digit, it doesn't make sense to go to more accurate digits. Okay, so basically what we call significant figures is all accurate digits and one uncertain digit. You're allowed to guess one digit but no more. So the scientific definition of significant figures is all accurate digits and one uncertain digit. Now, when you report a measurement, you should include only significant figures, but sometimes you'll be forced to include zeros that are not significant because zeros are also used to hold decimal places. For example, let's say this device goes in steps of 100. Let's say 0, this is 100, 200, 300, and so on. And you're trying to measure the length of this object. Okay, so there is no question that the length is between 100 and 200. Okay, and then you're allowed to guess one digit. Let's say the second digit could be 5, 6, 7, so maybe 1.150, 160, 170, and so on. Okay, now this is the accurate digit, the 1. The 5 is the one uncertain digit we're allowed to guess, but this 0 over here is not a significant digit. But if you do not include it, this number will lose its meaning because it will be 15 instead of 150. Okay, so in this case the 0 has to be included in the report of measurement because it is to hold decimal places. Now the question is then, how do you distinguish between zeros that are significant and zeros that are not significant? Because sometimes they can be significant. Well, there are some rules that help you to decide whether zeros are significant or not. The first one is the only digit that can be included in a report of measurement that is not significant is only 0. The only digit that can be reported as a non-significant digit in a report of measurement is 0. So all non-zero digits in a report of measurement are significant. All non-zero digits are significant. and tailing zeros before the decimal point are not significant. For example, if you take the number 2100, the decimal points over here, these tailing zeros before the decimal point are not significant. They're there only to tell us the 2 is 1000, they're placeholders. And the same thing about leading zeros. Leading zeros are not significant. For example, if you take the number 0.0012, these zeros are not significant. They're there to tell us this 2 is actually 1. I mean, this number 1 is actually 1 in 1000. All right. And then tailing zeros after the decimal point are significant. For example, if you take the number 2.3400, these 2 zeros are significant. The reason is these zeros are not used to hold decimal places. If you do not include them, it doesn't change the meaning of the number. The only reason you include them is if you're sure they're significant. So tailing zeros after the decimal point are significant. And zeros between significant digits are significant. For example, if you take the number 2001, okay, this digit over here is less accurate than the one digit over here. So if this digit is significant, then obviously this digit is significant because it's less accurate than this one. All right. So these are the 5 rules, that you can use to determine whether zeros are significant or not. All right. For example, let's take the following. Let's say we have the number 200.0. Let's see how many significant digits we have. This digit over here, this 0, is significant because it's a tailing 0 after the decimal point. This one is significant because non-zero, and these 2 zeros are significant because they are zeros between 2 significant digits. So in this case, all the digits are significant. So we've got 4 significant digits in this case. We have 4 significant digits. They're all significant. Next, we're going to look at operating with significant figures. Operating with significant figures. That is adding, subtracting, multiplying, and dividing. First, let's look at addition or subtraction. Addition and subtraction are not independent processes. Subtraction is simply the addition of the negative. Now, the general rule is when you add or subtract 2 numbers, the result cannot be more accurate than the numbers that are being operated on. Okay, so the sum or the difference should have the same number of decimal places as the number with the least number of decimal places. Okay, so the rule is the sum or difference should have the same number of decimal places as the number with the least number of decimal places, the least number of decimal places. The result cannot be more accurate than either of the numbers involved in the calculation. For example, let's say we're trying to add the following numbers. Okay, let's say we have 2, 4, 5, 6, and then we got 3.12. Okay, so this one has 3 decimal places, this one has 2 decimal places. The sum cannot have more than 2 decimal places. The sum should have only 2 decimal places. So normal addition will give you this one, 6, 7, 5, 5. But look, in this case, we're saying is, we're not saying this number is 0 over here. We're saying we don't know this number. Okay, it's not significant. So this sum over here is obviously not 6 because we don't know the number over here. All right, so the significant digits are these numbers, but we have to stop at 2 decimal places. Now, if this number is 5 or more, we go up. If this number is below 5, we go down. Okay, so this is reported as 5.58 because this number is more than 5. Okay, so the general rule is the sum or the difference cannot be more accurate than either of the numbers involved. So it should have the same number of decimal places as the number with the least number of decimal places. Next, let's look at multiplication or division. Multiplication and division are basically the same operations. Division is multiplication by a reciprocal. In this case, we go by the number of significant figures. The product or the quotient should have the same number of significant digits as the number with the least number of significant digits. So the product or quotient should have the same number of significant digits as the number with the least number of significant digits. Number of significant digits. For example, let's say we're multiplying the following product of 2 significant digits. Let's say 22 times 2. Okay, obviously you will get 44, but this one has 2 significant digits, this has only 1, so this one cannot have more than 1 significant digit. And remember, the only digit that can appear in the report for measurement as a non-significant digit is 0, so this has to be reported as 40. Okay, if this number is 5, if this number was 5 or more, then we'll go to 50, but it's below 5, so we round this to 40. So we have a number with 2 significant digits multiplied by a number with 1 significant digit. This result cannot have more more significant digits than 1. So we have to replace this one by 0, because 0 is the only digit that can appear as a non-significant digit. Now let's look at standard notation. This is a way of writing that allows you to avoid zeros that are not significant. Basically, it means expressing a number as a product of number between 1 and 10, 1 inclusive, and a power of 10. This is expressing a number as a product of a number between 1, that's inclusive, and 10, and a power of 10. A power of 10. Let's demonstrate by means of an example. Suppose, let's say we have the following number. Let's say 23400. We want to express it as a product of a number between 1 and 10 and a power of 10. So to make it a number between 1 and 10, we should take the decimal points that are over here to this location over here to make it 2.34. But to do that, we divide by 10, by 100, by 1000, by 10,000, right? So we have 2.34. Since we are divided by 10,000, we have to multiply by 10,000, okay? So that is the standard notation for this number. And the same thing about smaller numbers. Let's say we've got 0.032, okay? Now, to make this number a number between 1 and 10, we got to take the decimal point over here. To do that, we have to multiply by 100, right? So it will be 3.2 times 10 to the power of -2. Since we multiply by 100, we have to divide by 100. How about if you have a number, simply let's say 2. How do you write in standard notation? It's already a number between 1 and 10, and then we have to multiply by 1, and 1 is 10 to the power of 0.